All right, calculus. Welcome to day 3 of U substitution, section 5.5, the last section in chapter 5. And in some calculus classes, possibly the last section of the class, though a lot of them do talk about area, and we're going to do that starting on Monday, maybe even before you get some 6-1 notes. I find a way to get a lot of paper, whether that's a notebook, computer paper. No matter how this goes, folks, I'm going to have to get things from you, whether that's homework, quizzes. We're going to have to find a way. Again, right now, I am operating under the assumption I can see you again on April 14th, that Tuesday after Easter break. We can go back April 8th. Currently, the governor said, but April 8th is a Wednesday. That's you are starting spring break. So I don't think legally we can change spring break. I don't know. Let's hope everyone listens, abides by extreme social distancing, or we're going to be in a difficult spot with stats and calculus. But we have to find a way to get these grades. All right? So don't think about that right now. Let's hope we can see each other again April 14th. Evaluate each indefinite integral. So the whole lesson for this video, indefinite integrals, all right? Don't have to worry about bounds. What I want you to do is I want you to look at that. Again, if you need to pause, try to make a guess. What do you think U has to be? All right, so make a quick guess. What do you think U has to be? Again, pause this if you want. Work it out off to the side. But what you need to look at, you have two different kind of functions. This could be f of x, and that could be g of x. If you let u be 2x, then du would be 2 dx, and you would have nothing for this. Whereas, if you let u be x squared plus 3, you'd be then raising u to the 4th. Then your du would be 2x dx. So there's your answer. All right, little guess and check. You obviously want u to be x squared plus 3. Then you'd be raising u to the 4th. You might hear Elsie on the baby monitor. She should be sleeping. She's gotten into a pretty nice routine, and she's going to nap for 3 hours. She's going to stay up there. She wakes up early. She's going to fall back to sleep. All right, so if u is x squared plus 3, then du would be 2x dx. And that's exactly what you need. You need to substitute something in for 2x dx, and you got it. That's du, that's u, all is good. So this is simply going to be u to the 4th du. 1 power up divided by the new power. What is u? X squared plus 3, so you plug that in for you. So what I want you to do in this section is I'm going to show you each question, then I want you to pause and make a guess. What is u? What's du going to be? All right, so this one right here. All right, I'm going to take the antiderivative of that. What would be u? What would be du? All right. Anytime we're raising something to quite a large power, taking the square root of it, something like that, that's probably going to be u. All right. Going to want to look at this. If u is x to the 3rd plus 5, I would be raising u to the 9th power. That is taken care of. And the antiderivative of 3x, or x to the 3rd, would be 3x squared dx. So I just have to do a minor tweak. Then I would have everything I need. So that's what I'm going to do. I'm going to let u be x to the 3rd plus 5. Just going to move here. That's u. It'd be raised to the 9th. And I need to plug something in for x squared dx. If I take the derivative of x to the 3rd, I would get 3x squared dx. But all I want is what? What do I want? I just want to plug something in for x squared dx. So in order to get x squared dx, I would simply divide both sides by 3. So x squared dx would represent 1/3 du, and I rose u to the 9th power. 1 power up divided by the new power, plus c. That's 1/30th. What is u? X to the 3rd plus 5. Raise it to the 10th, plus c. Take the antiderivative of that, chain rule, and you'll get what we began with. Remember, you can always check your answer here. All right. I know that's last video, I said, anytime we see a denominator, that will most likely be u. But remember, when you're dealing with natural log x, what's the derivative of natural log x? 1 over x dx. So we want that to be u. Then I'd have u squared. And if I take the derivative of u, again, I get 1 over x dx. Everything would be substituted in for. All right? And I've kind of shown that that is going to be u. That's going to be du. We got it. I didn't have to tweak du at all. So it's going to be u squared du. Antiderivative, 1 power up divided by the new power plus c. What is u? U is the natural log x. Plug that in. All right. Hopefully we're feeling a little bit better about these. U substitution can be a challenge when you first learn it for sure. Especially you have to do it through these videos, and that is, believe me, not the way I wanted to go as well. But many times in life, as some good books I'm reading right now, you don't get to choose your circumstances, but how you move after that. All right, we're going to do the best we can here, because there's no other way. All right. Now, probably going to want this to be u. And I did write it there. But anytime you have e to some power, again, in my master's degree classes, I mean, I was always integrating with e to the x. All right, it is used so much in advanced stats formulas. The sweet Euler's constant. And exponential functions are just everywhere. It's even in the integral of the normal curve. All right, so if this is one you could maybe check too on your own just by doing the antiderivative. So if u is x squared, I would then have e to the u. What is du? 2x dx. And that's what I need. I need to plug something in for x dx. So I divide both sides by 2. And I'm just showing here that is u. That is going to be something with du. It's going to be 1/2 of du. All right. So again, from here, x dx would be 1/2 du. 1/2. E to the u du. What's the antiderivative of e to the u? It's e to the u here plus c. What is u? Again, you could check this little chain rule. You could check this by just taking, just guessing antiderivatives. Take the derivative of that, and that's what you'll get our starting point in example 4. All right, I only have a certain amount. You know, I want to make these videos not incredibly long. It takes too long to upload them. I also have a baby to take care of a lot of the day. So if you need to pause anything, go ahead. Go ahead and pause it. And then look at what's going on. Rewind it. Do whatever you want. I'm going to try to go through these examples slow. I'm not going to say, hey, look, here it is. See how to do it type of thing on these notes. That's a promise. If you got any concerns, please email me. I'm checking my email constantly. I will get back to you. I'll make videos to correct anything I mess up or to clarify. One of you said if I could speak louder, that'd be great. Lovely Elsie had RSV and passed it on to mommy and daddy. So my voice doesn't sound great. I'm highly congested. I have turned the volume up, so hopefully I sound loud enough. All right. I can only let this be u. There's no other function with x here. All right, so u is definitely going to have to be 2 minus x. That's going to be u. It's going to be raised to the 6. I need to plug something in. How about a different color for dx? Well, if u is 2 minus x, take the derivative. Du would be negative dx. So that means dx, and I need to plug something in for just dx, would be negative du. All right. That's u, that's negative du. What am I doing to u? I'm raising it to the 6th power. You can always put a negative on the outside. You can put it here. It doesn't matter. There or there, doesn't matter. 1 power up divided by the new power. Plug in 2 minus x for u. There we go. All right. I feel like we're going to be really prepared with these because I'm doing really all the homework exercises from this section, and that's the best thing to do. Best thing to do is those homework exercises as practice. All right, so what do we got here? Again, if you let u be x dx, or if you let u be x, sorry, then du is simply dx, and you're missing that part. So I definitely want to let u be that denominator. Then I would have something over u squared, or u to the negative second. And if I let this be u, then du would be 2x dx. I need to plug something in for x dx, as I have there. So I'm going to divide both sides by 2. 1/2 du would be, here's what I recommend doing, okay? That will be 1/2 du. All right, so it would be 1 over u squared with a 1/2 on the outside, du. Or, again, 1 over u squared is u to the negative second, right? 1 over u squared is u to the negative second. 1 power up divided by the new power. That looks odd. Be a negative 1 over 2u plus c. What is u? Use that. You could distribute. That's fine. That's also a good answer there. All right. And if I make any boo-boos, let me know. This is going to be the last page for section 5.5, day 3. Probably going to break up the next, gosh, how many questions do we have left? Next 10 or 12 in 2 different videos, because I want to teach you what you should probably do with the bounds. All right, again, hopefully I can show you more tricks in person. If not, I'll make sure we know all of Calc 1 and a little bit of Calc 2, at least, via these videos. All right, again, guess and check. If I let this be u, then du is 3y squared dy, and we just ain't going to make that work here. So I'm going to let this be u. Again, when I have a square root involved, I really want to investigate, or something raised to a big exponent, really want to investigate that being u. Okay? So if I let this be u, I would have u to the 1/2, check, and then du would be 8y to the 3rd dy. Well, I have y to the 3rd dy, so all I have to do to get y to the 3rd dy is divide both sides by 8, or multiply by an 1/8, and then boom, I got what I need. So there'd be a 1/8 on the outside. D would be, or then u would be raised to the 1/2. Again, this right here would represent 1/8 du. All right, so it'd be 1/8 u to the 1/2 du. And 1 power up divided by the new power, or multiplied by 2/3. That'd be a 1/12 u to the 3/2 plus c. What is u? 2y squared minus 1. Plug it in, plus c. All right. Then this one actually, it's interesting that they had this in there. Folks, I would honestly just do the antiderivative. Because if I let u be secant 2 theta, then d theta, or I'm sorry, du would be, secant 2 theta, tan 2 theta, and then multiplied by 2 instead. And then I'd have, there's really not a case where u is something and then du is most of that. That's just odd. Instead, I would just take the antiderivative. All right, so let's say, and the antiderivative is 1/2 secant 2 theta. If you were left, if f of x was 1/2 secant 2 theta, then the derivative of that, again, check your antiderivative by finding its derivative. The derivative of this would be 1/2 secant 2 theta tan 2 theta, because it's secant u tan u, or secant x tan x, and then I got to take the derivative of this, which would be 2. That's exactly what I started with. So that is simply the answer there. So I can just take its antiderivative. All right? Now, on the final, you would have to know when to apply. So I wouldn't ask you integration by parts. That's solid Calc 2. But when to just take the antiderivative, when to do u substitution. Both of those are fair game. All right, folks. If I let u be cosine theta, then du is negative sine theta. I can't have, there's no situation where I have du raised to the 6th power. No, no, no. So instead, I'm going to let u be sine theta. So I would have u to the 6th. And then du is right there, cosine theta, d theta, right there. I would have u to the 6th. This right here would represent du. So that's exactly what du is. This is simply u to the 6th du, 1 power up divided by the new power. Plug in sine theta for u. And the last one with day 3, I like this one. All right, so we just talked about one was secant and tan, but this is secant to the 3rd x. So secant x to the 3rd tan x. So here you got to be tricky. Again, calculus requires you to do a little critical thinking. Another way to write secant to the 3rd is to write it as secant squared x, secant x tan x. Okay, that is another way to write it. And the reason I want to do that, because if I let u be simply secant x, this would be u squared. What's the derivative of u? Secant x tan x dx. So that's it. All right, that's exactly what I want to do. So I would have u squared du, 1 power up divided by the new power. And boom, again, you can take the derivative of this. Bring down the power, secant squared x. Take the derivative then of secant x. Because again, it would be like bring the power down, u, 1 power less, u squared. Then you take the derivative of u. The derivative of secant x is secant x tan x. You get back to your original. All right, this is the end of day 3. Again, watch this again, rewrite your notes, get a few notebooks for this. It's a very important sections that we have to unfortunately cover via videos. Again, my hope is to see you April 14th, that first day back. I made a mistake in the video. It would be April 14th. That is that Tuesday. The 12th is Easter Sunday. So I hope to see you. Again, I'll give you a refresher over this. More info to come later. Your goal is to get through Chapter 5 this week, get through homework set 2. Yes, eventually I will grade your homework set 1. My concern, though, is pumping out the videos right now. Then I will get to that grading. This is Yak Math Videos, signing out.